In this lesson, we're going to learn how to perform function operations in the same way that you can add, subtract, multiply, and divide numbers or expressions. You can actually do that with entire operations. So let's check out some new notation. This is read as f plus g of x. It is exactly the same as taking f of x, that function, and adding it to g of x. So you're just going to be adding two functions together, whereas f minus g of x would just be subtract the two functions, but of course, pay particular attention to the order that they're in. Okay, subtraction is not commutative. And then, as you would expect, this would be multiply your two functions, f times g of x and f divided by g of x. This is one where we're going to have to worry a little bit about some restrictions in our domain. All right, so we're going to be stating the domain of our new function because it's something we always consider in math is, what can we plug into a function where our values make sense? So you want to make sure, general processes, state the domain of your original functions. Think about the two. And when you do that, always remember that even roots can't have a negative radicand. So even roots are like the square root or the fourth root or the sixth root, which can also be written in fraction form, like to the 1/2 power or to the 1/4 power, or this one would be to the 1/6 power. Okay, and also remember that you cannot divide by 0. So the domain of your new function will be the intersection of the original two domains. And I'll show you what that means with an example. And there's always something extra we got to watch for with division. With division, you must also restrict any values that will cause the denominator to equal to 0. All right, so let's illustrate this. Here are two functions, f of x and g of x, and we're going to do the 4 operations. We're going to add, subtract, multiply, and divide here. And then I'm going to show you how to evaluate for a specific value. So the first thing I do is I look at f of x and I spot degree is 2, so I know this is quadratic, and all quadratics have a domain, of all real numbers. So I'm going to fill in interval notation. Domain of my original is negative to positive infinity. G of x is going to be linear, so all lines also have a domain of all real numbers. There's nothing weird going on there. So let's begin by adding f of x plus g of x. So what I'm going to do is add f of x plus g of x. And now, guys, it's just a matter of adding two polynomials, so you're just combining your like terms. So this would be equivalent to negative 9x squared. I have a positive 15x and a negative 3x would be positive 12x. And then I have 36 and minus 4 would be positive 32. I have no more like terms, so here is my new function. It is also quadratic. Now, to state the domain, I always think about the intersection of my two original domains. Well, where do negative infinity and negative infinity intersect? It's going to intersect for all real numbers, okay? All right, so let's do subtraction now. So subtraction, just pay attention to the order. This time I'm told to do g of x first, so I'm going to do negative 3x minus 4 minus my second polynomial. So what I need to be careful with is that I make sure that because it's subtraction, I'm going to put the entire f of x in parentheses. So negative 9x squared plus 15x plus 36. So this is really just checking again, can you subtract polynomials? All right, so this is equivalent to, I always begin by first distributing. Think of this as a negative and I distribute it to all three terms. So I'd have positive 9x squared, negative 15x, and negative 36. So I look for all my like terms. I have a positive 9x squared. Then I go to my linear terms. There's a negative 3x and a negative 15x would be minus 18x. And then I go to my constants. I have a negative 4 and a negative 36 would be negative 40. So I have no more like terms. So again, I get a quadratic function here. And the domain, well, I've already talked about it before. It's the intersection of the two sets, negative infinity to positive infinity. Here's a hint. The domain for adding, subtracting, and multiplying will always be the same. Division is the wonky one you got to watch out for. All right. We are going to do multiplication now. f of x times g of x, which, folks, is really just going to be polynomial multiplication, so it's going to be lots of distributing. So why don't you see if you can pause the video, work ahead of me, and see if you can multiply these two. Hit play when you're ready to check. So I've written my two polynomials. I always begin by multiplying the smaller polynomial and distributing that to the larger. So I start with this binomial and I distribute the negative 3x. Then I need to distribute this negative 4. I'm going to write that in green here. So there's all of my terms. When I multiply, now I just have to combine like terms. So that produces 9x cubed minus 9x squared minus 168x minus 144. Again, domain is the same as the previous three. The intersection of the two is all real numbers. Okay, let's check division, the trickiest one, because there's some new things you've got to think about with the domain. So order is definitely specified here. Make sure you are putting f of x in the numerator. Okay, so what I need to do now is my division, and I have a quadratic divided by a linear binomial. So since the top is quadratic, I'm going to try to factor this to see if I can cancel any like terms, or like factors would be a better phrase. So in the top, I'm going to begin by factoring out my GCF, which looks like negative 3. So I've zoomed in here to help my eyes. This gives me positive 3x squared minus 5x minus 12. I'm going to at least factor out negative because I hate when my leading coefficient's negative. So I'm going to make this 3x plus 4, negative 1 times 3x plus 4. Okay, so I have a trinomial here in the numerator yet. I'm going to check and see with some guess and check to see if I can factor this further. And, you know, get some clues. There's a really good chance when you're given textbook problems that one of them might be 3x plus 4. All right, so factors of 3x would be, or 3x squared would be 3x and x. Factors of 12 could be 3 and 4. So you know what, I'm going to try 4 here and 3 here, and one of them's got to be negative. So I check my outer product. This would be negative 9. This would be positive 4. Yep, that adds to negative 5x, so I'm good. Just recopy the bottom. This is negative 1 times 3x plus 4. Now, check it out. What cancels? Only factors that are identical. This is identical and this is identical. And I can do negative 3 divided by negative 1. We'll at least switch to positive 3. So this gives me 3 times x minus 3 on the top. You will often see this multiplied back out to be 3x minus 9 for a final answer. Because technically when things are simplified, they've got no like terms and no parentheses remaining. Okay, so my domain is the intersection of the two. However, one extra thing with division, check out your denominator at the very beginning. This right here, anything that would cause this to be 0, we need to restrict. So my domain, if you need some help off on the side, what I do is I take my whole denominator, negative 3x minus 4, and I say it can't be 0. Add 4 to both sides, and I get negative 3x can't be 4. Divide by negative 3, and x cannot be negative 4/3. So now my domain is everything except for negative 4/3. So how do we write that? It would be negative infinity to negative 4/3 with parentheses, meaning it never touches, union negative 4/3 to positive infinity. Okay, so what that means on the number line is it includes absolutely everything is a possible value with the exception of negative 4/3. All right, last thing that we're going to do here, let me zoom back out. Got this one little floating thing there. Okay, would be this find g minus f of 4. So folks, there's two ways of doing this. I'm going to show you, I may show you both. In my opinion, here's what's typically easiest. You do g of, plug the 4 into that, minus f of 4. Okay, that's one way. The other way is if you already found g minus f of x, which we did up here, you could use this and just plug it in right there. So it's really a matter of preference. I think it usually depends on what you've already done to get your answer. All right, so first way, if I plug 4 into g of x, right here I'd have negative 3 times 4 would be negative 12, minus 4 would be negative 16. And then if I plug 4 into this one here, so meaning I'm plugging in 4 here and here, I get negative 48. So minus negative 48, negative 16 minus negative 48 is 32. Okay, the alternate way of doing this is to go where you already did g minus f of x, which is right here. I'm highlighting it. You could just plug 4 into that. And I get 32 as well. So you have to get the same answer both ways.